Search your documents with a few lines of Python. You will build a small search engine with Whoosh, index a tiny corpus, run ranked queries, handle exact phrases, and recover from misspellings. By the end, you will see ranked document IDs for a query. Try a phrase search that requires adjacent words, and handle a fuzzy query that tolerates typos. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Search matters because it optimizes relevance, the measure of how useful the top results are. Relevance trades off with latency and index size, so you will learn where you trade memory for speed. If you tune scoring, you can boost precision at the top of the list. And if you accept fuzzy matches, you increase recall, but may introduce noise. In practice, Whoosh handles thousands of small documents comfortably and returns results in milliseconds on a single machine. Conceptually, Whoosh stores inverted lists that map terms to documents. When a query runs, Whoosh scores documents by how well terms match, using a scoring model such as BM25, which balances term frequency and document length to rank relevance. It shines for moderate datasets, fast prototyping, and when you need full text features like phrase search. A clear limitation is single process scale. For very large corpora, you move to distributed indexes or ANN systems. We will build a minimal example that indexes a tiny corpus of short tech articles and demonstrates ranked one-word search, an in-memory Whoosh index, ranked queries, phrase search, and a fuzzy misspelling handler. Now we start with a very small ranking example. This snippet ranks tiny documents by a one-word query using plain Python. It shows a hand-rolled scoring method over a small corpus of short tech articles to make the idea concrete. The code counts how often the query term appears in each document and uses that count as a simple score, then sorts documents by that score. This exposes the intuition behind inverted indexes and relevance without any library setup. If you change the parameter that limits results, you restrict how many top documents are returned. If you normalize by document length instead, longer documents stop dominating the ranking. Next, we create the Whoosh index and store the documents. This snippet built an in-memory Whoosh index and stores the documents. It defines a schema with a text field for content and a stored ID field, then opens a RAM index and writes each short tech article into it. Building the index demonstrates tokenization, storing fields, and how Whoosh prepares inverted lists for fast lookup. If you change the analyzer or add an n-gram field, you will affect match behavior and index size. Using RAM storage makes searches fast for demos, but increases memory use. On disk, you trade a little latency for persistence and lower memory pressure. Next, we run queries against that index and collect ranked IDs. This snippet queries the index and returns ranked document IDs. It shows how to open a searcher, parse a simple one-word query, execute the search, and extract the document ID and score for the top hits. The snippet also highlights that Whoosh exposes scores, so you can inspect or re-rank results. If you change the result limit parameter, you will return more or fewer candidates and affect throughput. If you switch the parser or scoring model, such as explicitly choosing BM25, you will alter ranking quality and sensitivity to term frequency and document length. Next, we require adjacent words to match exactly in order. This snippet performs a phrase search that requires adjacent words in order. It demonstrates building a phrase query for a two-word phrase found in our tech articles and running it against the index. Phrase search checks positional information in the inverted lists, so matches only succeed when tokens appear next to each other in the right order. If you adjust the phrase slot parameter, you allow a small number of words between the phrase terms and widen matches, increasing recall but possibly lowering precision. Phrase search is great for exact feature detection like model names or quoted lines. Next, we tolerate simple typos with fuzzy matching. This snippet handles a misspelled query using a fuzzy matching plugin. It shows how Whoosh can expand a user query to accept near matches and return documents even when the query has a typo. Fuzzy matching works by allowing a limited number of edits between the query term and index terms, so you recover relevant documents that otherwise would be missed. The key adjustable parameter is maximum edits. Increasing it raises recall and finds more matches, but risks more false positives and slower searches. Use fuzzy matching sparingly on frequent terms to avoid noisy results and performance costs. Quick recap. This is a small Whoosh search pipeline that indexes text and returns ranked results. Use it for prototyping, moderate datasets, and features like phrase or fuzzy search. One caveat. Whoosh is single process and not built for web scale without sharding or moving to a distributed engine. For the next step, tune the BM25 parameters K1 and B in the Whoosh scorer to see how changing term frequency weighting and length normalization affects relevance on your corpus. That single tweak often gives measurable gains. If you found this practical and want solid, hands-on IR guides, subscribe and explore the rest of the search series.